Good evening, everyone. Happy Engineers Day to all. This is Reshma Shetty, Manager in Epicons Consultant and today's webinar coordinator. Welcome our speakers, all the panelists, seniors, participants in this webinar. Today's webinar subject is soil supervision and likely risk. Before proceeding, I request all the participants to put your questions in QA box in the chat box. Without wasting much time, I briefly introduce
Hello. Hi, Reshma. Reshma.
हाँ सर.
अजून पार्टिसिपंट फक्त 41 झालेले आहेत. आपले 138
चालू करा.
Good evening, everyone. Happy Engineers Day to all. This is Reshma Shetty, HR Manager in Epicons Consultant and today's webinar coordinator. I welcome our speakers, all the panelists, seniors, and participants in this webinar. Today's webinar subject is Soil Retaining System, Design, Supervision, and Likely Risk. Before proceeding further, I request all the participants to put your questions in the QA box, not in the chat box, which disturbs other screen. Without wasting much time, I briefly introduce Mr. Jayant Kulkarni, who is founder member and managing director of Epicons Consultant since 1985. He is graduated from VZTI Mumbai, further pursued masters in structures in the same college. He has specific interest in various areas of engineering like pile foundation, codal provision, seismic retrofitting, tall buildings, concrete mix design, advanced NDT and evaluation, conservation of heritage structures, and Indian aesthetics. Epicons has successfully completed more than 8,500 projects under his technical and administrative leadership in multiple avenues of civil engineering like structural design, project management, architecture, NDT, and infra. I'm proud to tell you that company received second time consecutively Industrial Excellence Award 2021 from Institute of Engineers. Now I request Jayan sir to give introduction of EFC.
Good afternoon. Warm welcome to all the participants, speakers, and all the eminent persons who are present in the audience. This activity of knowledge sharing has started in 1999, and since then we are pursuing this activity for more than 23 years. This activity is conducted under Epicons Consultant Private Limited, ISO 9001-2015 certified company. One of the well-defined objectives is imparting technical knowledge to interested parties and society at large. Our inspiration, it goes to our friend, philosopher and guru, late engineer A.P. Remedios. Now, quick overview. Epicon Friend of Concrete has conducted 79 workshops in last 22 years and 33 webinars in last 2 years of after pandemic. We started webinar series since lockdown through our unit Epicon Friend of Concrete dedicated to training. There are 2 photographs of the participant when we used to conduct workshop. EFC is an humble effort to create a knowledge sharing platform and develop a facility for continued education for practicing structural engineer, corporate consultant, government, semi-government authorities, architect builders, and of course, faculty and students of engineering college and architectural college. This is a quick overview of the webinars conducted in last few months. Today we are at webinar 135, soil retention systems, design, supervision, and likely risk. And 136 will be announcing within 1 week. I will request everybody to fill the feedback form and suggest the desired topics. Now, coming back to AFC team, apart from myself, all other director and unit heads, Anand Kurani, Ravindra Deshpande, Arvind Parulekar, Parashar Mugi, and Pandey are the key persons who are involved in conceiving the subject, developing the subject, and presenting the subject. And with all that, our entire team of Epicons is involved in designing and making any webinar successful. Thank you very much. Over to Reshma.
I quickly introduce our moderator and director of Epicons Consultant, Mr. Parulekar. He is graduated from SPC Andheri in 1987, further pursued masters in structures from MS University, Vadodara. He is having more than 30 years of experience in the field of structural design. He conducts various programs on NDT for PWD Meta Nasik, ISSC Mumbai, PWD Thane, SIDCO Navi Mumbai, and of course, webinars of EFC. Appointed auditor by RMCMA for RMCA plant in 2010-2012. He has experience of working more than 2,500, including structural assessment project, large volume NDT projects, complex challenging structural design projects, and infra projects. He developed in-house well-equipped NABL accredited lab with the team of 35 engineers and technicians under Epicons. Now I request Parulekar sir to give preamble.
Thanks, Reshma. Friends, welcome to webinar 135, Soil Retaining Systems, Design, Supervision, and Likely Risk. Am I audible clearly, Reshma? Hello.
Yes, sir.
Yes, sir, you are audible.
Yeah. We are at the end of one rigorous monsoon in Mumbai, and I need not tell Mumbai's structural designers the importance of soil retaining systems with reference to that. As professionals, I am sure each of us must be having at least one critical site which we first think of when we hear about or witness very heavy rains at the start of the monsoon. With increasing parking requirements, we are going deep into the earth, and with no space around for providing natural slopes, we don't have any other option than to retain this soil vertically by some kind of retention system, most popularly with shore piles, especially in Mumbai. Design of these systems is primarily a domain of geotechnical engineer, although the statutory responsibility of their safety is of structural engineer, as of now at least, of the project or the project. Hence, at least for that, as a structural designer, we must understand the principles used for the design, the parameters affecting the same, and the risks involved in design as well as the construction. Today, Sri Shekhar Vaishampayan, noted senior geotechnical engineer from Mumbai, will explain us exactly the same, which I am sure will benefit all of us. Such retention systems have been extensively used in other countries, especially Gulf countries, for last many years. And our second speaker, Mr. Abhijit Kulkarni from Bureau Apart, Mumbai, will share his experience about them. I'm sure all of us will enjoy this seminar. Over to you, Reshma.
Now I quickly introduce our first speaker, Engineer Shekhar Vaishampayan. He is MTech in 1984 from IIT Madras, BTech Civil from IIT Madras. He is director at Subsurface Consultants Private Limited. He is having more than 35 years of experience with more than 5,000 projects in all types of
verticals,
subsoil condition and in all types of vertical foundations, retaining schemes, ground improvement, soil improvement, hill slope stabilizations, pavement designs, forensic analysis of failures. He is member of Indian Geotechnical Society, New Delhi, and also member of Institute of Engineers. Now I request Shekhar Vaishampayan sir to start with the lecture.
Yes. Good afternoon to all my professional colleagues now. I would like to start sharing the screen first. One second. Is my screen visible to you?
Yes, sir.
Yes. Thank you so much. Yes. Okay. There you are. We are having to go to have a discussion today on soil retaining systems, design, supervision, and likely risk. At the outset, I would like to thank Epicons Friends of Concrete (EFC) for inviting me to participate in today's webinar. Webinar 135 is about soil retaining systems. Idea of this webinar really came from a common concern we felt as civil engineers, as quite a few retaining systems actually have failed during this monsoon. And endeavor of this webinar is to disseminate the information so that the civil engineering fraternity relooks at the site conditions, situations, and the failures can be prevented in future as much as possible. Before starting, I would like to thank directors of Epicons, Mr. Jan Kulkarni, the main driving force behind this webinar, Mr. Anand Kulkarni, Mr. Arun Gorekar, Mr. R.D. Deshpande, and not to forget support staff who worked tirelessly behind the screen to make this webinar possible. Now, let us together make this webinar a success also. Let me start. Yes, a rapid pace of urbanization in Maharashtra state has a population migrating from rural areas to towns and cities. The basic infrastructure as such as housing, water supply, sanitation in cities is therefore stretched to limits. This effect gets magnified in Mumbai metropolitan region as the migratory population is not limited only from Maharashtra state but also from the whole country, as Mumbai is the economic and commercial capital of India. Okay, since Mumbai is an island, there is a limit on horizontal expansion. So government and administrators are then forced to promote vertical growth by taking suitable measures. This has helped actually just force developers also to construct multiple number of basements below ground level to house different services such as parking, water tanks, sewer treatment plants, air conditioning plants, and so on. And in quite a few projects, the basement excavation exceeds well below 10 meters to 10 to 15 meters. Okay, so let's look at right from the start, from the basics now. We are going to look at some basics first so that we have a starting point. Generally, excavation is done these days by excavators. Excavators like JCB, Poclane, or a good quality Poclane actually has a reach of about 4 meters. So therefore, generally, as and when the excavation crosses 4-meter depth, one would tend to call that as a deep excavation. Most common depth of excavation on account of utilities, you will see, is between 7 to 10 meters. And in many cases, it can go up to 15 to 20 meters also. In most of the project, what happens is the excavation contractor comes to site. He has a tendency to carry out the excavation nearly in vertical line. It stands for short time. It gives a false sense of security to people. Kuch nahi hota hai. Then basically, but all of us know in our heart that this is going to fall down. Soil will remain stable for a short while and then it will fall down and it will take at a natural slope of natural angle of repose or internal resistance. but then which will mean that it has to occupy and consume a lot of space. Now, is it possible for us? Because in most of the projects, the clear distance between the basement face and property boundary is only about 1.5 to 3 meters. In such cases, excavation with safe slopes, as you have said initially, would simply encroach into adjoining property. The main calamity or a main critical point.
Vaishambhan sir, 1 second. I think your slides are not moving.
Slide not moving.
Now it has been moved.
Oh, this is what I'm talking about right now.
Okay, now that seems to be. Take it. Okay, I thought you are say next
No,
slide.
No, I'm not slept. No, I'm not slept yet. Okay. In case of the slope failure, the most hazardous thing that can happen is it will risk the life of people who are working in the basement region. And a failure line also traveling to adjoining plots will cause extensive damages to structures, also to services. To avoid this kind of situations, it becomes necessary to install the retaining system to stabilize the excavation slopes. Now, generally speaking, let's look at what kind of retaining systems are possible. We all know generally that the soils or the rock actually supports the foundation. And but then retaining systems are a typical soil structure. Systems are structures which support soil or rock, and they also are supported on the soil, but they support soil and rock themselves. So that means even inside in the retaining systems, there are two subtypes. One is a non-embedded and the second one is embedded type. Now let me explain what is non-embedded and let me explain what is the embedded type. Let me go to next slide. Basically, we can see non-embedded type retaining system is the one which is this is a system where you excavate first and then construct sequence. So bottom-up sequence. This supports soil fill behind them. So what one does is you excavate up to the foundation depth of the small depth, not deep depth, small depth, and that's why I'm calling it non-embedded. And then you construct the structure on top, whatever may be the structure, and then you fill soil behind that. Now, the examples of such structures are they're primarily gravity structures, stone masonry wall. Then you can have a RCC wall. And the RCC wall, the first type would be the typical cantilever retaining wall. Then the second type would be when the height of retaining wall becomes too much, you will have counterfort retaining wall. And in some emergency situations, one can even look at reverse cantilever wall, which is abutting the slope or the excavation side. Now, as the time has passed in the past, the other types of gravity structures also have been in practice, like reinforced earth walls, then gabions, crib walls. All the structures have the basis of these walls is the stability, translation, and rotation. Now, for achieving the stability, the minimum width to height ratio is is at least 0.7. Now, when you have a width to height ratio of 0.7, in our congested urban neighborhoods or with cities, there's hardly any space available. If you want to construct a basement below ground, and you cannot sacrifice width of 0.7 times the height, which will mean that the non-embedded type of retaining systems are not going to be preferred at all. Okay. Now, what is the other type of system? In embedded type retaining systems. In embedded type retaining system, we have install first and then excavate process sequence. In this, these structures are usually self-supporting. They derive the stability from the passive resistance experienced below the excavation depth. And there are also two types of structures in this. One you can see cantilever type embedded walls, and the other one is a propped cantilever type embedded walls. Now, what are these typical retaining elements you use under this head? You can use sheet piles, which is a very conventional old method. You can use box piles. You can use rolled sections to form box and then you can drive them. You can actually do contiguous piles. You can use second piles. You can use diaphragm walls, rectangular piles like vitre panels and all that. So maybe something else would be possible, but then these are all the major types used in practice. Okay, so as we said in the last slide, that we have a cantilever and a propped cantilever. to achieve proper cantilever, what you do is we can actually provide support internally and provide support externally. Internal supports will be horizontal struts and rakers from inside the excavation, and external supports will be deadman anchors from outside or tieback anchors. You can also do propping at the excavation level. Now, the propping, what does propping do for us? The propping actually allows us to reduce the spans, so the bending moments are reduced, and you can save on the reinforcement steel to be put into the retaining systems or retaining piles or retaining walls. And it also can suit the construction sequence. So propping can be done not only at one level, but it can be done at multiple levels also, depending on the site situation. Now, what are the, I'm just coming here to explain to you what kind of different retaining systems are in practice right now. Okay, so the first type is contiguous piles. Contiguous piles is it's a row of successive unconnected cast in situ concrete piles with a small gap of about 100 mm to 150 mm between the piles. Typically, these are called contiguous piles. These are very suitable in cohesive soils because arching of the cohesive soil prevents collapse of the soil in between. This is usually in a place where the groundwater table is not high. Permanent liners may be required sometimes, but this is typically called touching piles these days. This is a general misnomer because it is not supposed to touch each other. The gap between the piles is also expected to release the water pressure, if any. Now, let's go to the next slide. Okay, second piles. Now, just like contiguous piles with a gap in between, we have second piles. So this is also row of the successive overlapping cast in situ concrete piles. In this case, what happens is the typical overlap of 100 to 150 mm is provided, which is very similar to this thing. There we had a gap, here we have overlap. This is the typical of second piles. These are most suitable in non-cohesive soils with a high groundwater table. When the water is flowing in, you require to stop that water from flowing into the pit, and erosion of soil can be controlled. Now, the first in this case, first the PCC piles are installed, they're drilled and casted. Then this will go up to the excavation depth or maybe a little more than that, or maybe up to rock depth if the rock depth is before that. Then the RCC piles are drilled within next 3 to 4 days time to ensure that concrete or somewhat green concrete and achieve the overlap so that PCC pile can be cut easily. Then RCC piles are then installed and casted inside them with reinforcement. Now, the reinforcement is of course meant to carry the bending moment also. Now, the overlap between the piles is basically to ensure that the ingress of water is minimized. You can see in this picture, the water is practically not there. Now, let's look at the propping systems, different propping systems. Let's look at first external supports. The basic external support where the sufficient space is available. Traditionally, a deadman anchor has been used, and this has been basically used in ports and jetty constructions where a lot of space is available to you. Deadman has to be installed. Deadman has to be installed well outside the failure wedge, so that it has to develop the passive pressure on the face, and then that's how it actually allows to carry the tension in the string in the middle. But then this requires a lot of space. Once again, not possible in the urban setting. So a typical, very commonly used system would be to adopt tieback rock anchors. Now, where the space is at premium, tieback rock anchors are used. Now, anchors are used in this case to control deflection. They are also used to reduce the bending moments and therefore steel in the piles. It is possible that one may have one level of anchor, but then as the time may require or the excavation may demand 2 or 3 levels of anchors are also used. You can see in the adjoining figure here, the excavation depth was as much as 20 meters. This has not reached the final level yet, but you can see that there is a top rudder beam here, followed by anchor at maybe top 2 meter depth. On one side, there are only 2 levels of anchors. On the other side, there are 3 levels of anchors. So even within the small site, we had variation in the site condition, and we ended up with two different retaining systems. Okay, now let's look at the inside supports. What used to be done is a rakers on the right side. You can see there are rakers actually placed against the retaining walls. These are the very old method and possibly used today only in the SOS conditions. Like rakers would require this will, if you use rakers, it will obstruct your flow of work, so they are not preferred. They require very firm support at the bottom, maybe pile head or a column bottom or a raft at that bottom to be able to take this load. So, but you can see the situation on the right side where a complete horizontally braced struts are possible, and now they actually can be provided in different levels. And in general, in this case, enough space is left in between. You can see some construction equipment below, down here, yellow colored, and they are carrying out their work here. And the bracing has to be also designed in such a way or to accommodate the movement of the equipment below. The next typical structure would be diaphragm walls or rectangular piles, meter panels. Meter panels and diaphragm walls are basically brother and sisters. They are the same thing. So rectangular shape piles, either used using grab or in the shall we say baler, rectangular shape baler. You actually use them and to excavate this. These are very popular in the alluvial soils. You can see in north, you can in the places where there is a lot of clay. These are done actually very easily. You can see the considerable depth actually has gone into this. The truck is looks so small here. So this is probably maybe 20 meters or so. And they are not only rectangles, but also wherever the more stiffness is required, you can also use T-shaped diaphragm walls. So both these is also possible to you. And we can go to the next slide. The edgewood sheet piles, where initially probably people used only timbers and strutting actually, and then they went on to use steel sections to drive because it can be driven more easily if you got more strength. So you can see on the left side a typical straight sheet pipe followed by with slightly more moment of inertia, then a deep C, the Z shape, and it's a two C shape, like double C shape, inverse C shapes. These are all driven here. In this particular site, the bottommost was used. There is a locking arrangement at the end of each this thing. There is a male and a female joint here. So once they get actually inserted or locked into each other, they prevent ingress of water when the excavation is done. So sheet pipes were very commonly used and a preferred method. Now we are going to look at the next one. So all right, so we actually come to once again we have an urban setting here. You can see a lot of structures behind this, and we are forced to do contiguous piles. You could not do shore piles, or that is the second piles in this place, because they're either costly or shall we say not possible to execute. Maybe liners were required. I don't remember now, but then this is what was done. And what we did here was we excavated, and as we went on excavating, we went on doing graniting or shortcutting on this face by doing jali. Actually, you can see jali in some places here, and granited the whole face to make sure that water doesn't flow in and erosion of fines doesn't take place. Obviously, this we have to do in a fair season so that in the monsoon, when it comes to monsoon, we actually are prepared for this excavation. The pit is more or less dry. We can carry out excavation. So we can say this is a variant of the contiguous piles with shortcut. That is a variation. Now, contiguous piles can be also paired with bentonite piles. Like instead of doing this shortcutting on the front side, which is a negative side waterproofing, you can actually plug the flow of the water where it enters. So, like the water is entering from this side, you actually drill holes on the upstream side or between the shore piles and the property boundary, a small hole between two piles, and go right up to bottom and pour sand cement slurry. Not sand cement bentonite slurry. So it forms a low modulus concrete. It is very plastic in nature. So that also plugs the gap and doesn't allow water to come in. The next one. Then this is very commonly used now these days. Piles with rock bench and ledge. As and when like you have excavation depth X actually or H you want to reach, and way above that you beat bedrock. When you beat bedrock way above that, there's a tendency to use the strength of the rock to reduce the length of piles to economize the length of now the length of pile. Now what happens is the rock bench is provided only if bedrock is in good condition and it is present at depth well above final excavation depth. It will also require sufficient space from basement wall and property line to ensure adequate width of the rock bench. It is possible to design a length of retaining pile just as shown here, which is less than the final excavation depth, but it is better and safer to provide length of the pile right up to bottom of the excavation. At least that should be done. And rock bench, this rock bench actually is always very susceptible to excavation effort and can fall down. Hello? There's some disturbance. Okay, then let's look at the next option. In this next option, we have shotcrete connecting with the nailing and soil nails and anchors. This is actually not a install first and excavate, but this is actually a variant of the first method where you excavate first and then stabilize. What is done is you can see here clearly that when the sufficient space is available between the property line and the basement wall, you can try to adopt this. You excavate first and then install. You excavate first and then stabilize first. Stabilize and then go on to do in this work in steps. You first do a step excavation, drill the rock anchors or nails horizontally, put jali on top, then connect that or plaster that by putting a shotcrete layer so that you have stabilized this surface now. After stabilizing this surface, you will come to excavate next step and go on to do that gradually. You can see but here that there is a definitely step inside or you are losing more space of basement. So it is possible only where such a thing is possible. Such a space is available. Okay, so this is all we can have about the standard typical retaining systems. So I am now coming to an area where the risks involved in the design of retaining systems. Now at this stage, I have finished my segment of the types of retaining walls. I would like to discuss aspects of design of retaining systems. In the design of retaining systems, obviously, basic principles of statics are used where equilibrium actually has to be achieved and minimum requirements are computed. Now, describing the whole thing in detail would be like sitting in the classroom again in the college days. So our idea here is to share our knowledge with you so that these cues will act more like red flags to you in the future. So while designing as well as checking somebody else's designs. So like what are the things that we look at? So risk involved associated with in designs. So in design of retaining systems, you generally compute destabilizing and stabilizing forces. You can estimate them using standard practices, and length and reinforcement of the embedded retaining system can be easily worked out. What you will do is, see, let's look at three basic main steps. You can take summation of bending moments, set them to equal to 0. This will yield you minimum embedment depth of embedded retaining system. Sigma h is equal to 0 will yield you location and value of maximum bending moment. I don't want to tell you how. And third factor, sigma v is equal to 0, is not very relevant or not very important in case of retaining systems because they are not part of the permanent structure. These are basically enabling structures, and very rarely retaining piles are loaded with vertical loads. So design procedures for all of these are very well established, and there are many softwares available as well as standard reference books are also available. I would like to focus on likely errors that might creep in and result in failures. So let me go to the first one. The results in the likely errors in engineering parameters themselves. Now let me list them first of all, and then we'll take up one by one. Now design parameters for each stratum for soil and rock, where you establish or compute or estimate active or passive pressures. then the water pressure due to ground water table, then surcharge pressures because of various loadings on the edge of the excavation, then deflection of pile or retaining walls, then rockage, existence of rockage or evidence of rockage, and then assessment of possibility of hewing of clay and sand boiling conditions and its mitigation. So these conditions we are going to look at. So the first one would be that difference in the design parameters in site conditions. So first is design parameters. So what everybody does to site is, anybody now goes to site, you had drilled some boreholes, few boreholes, and after drilling a few boreholes, you come to conclusion and you calculate, you do some lab testing, calculate C, phi, gamma, UCS of rock, etc., until you estimate your design parameters. Now let's look at these two typical cases. The first case on left side, the perimeter is 84 meters, and we had two boreholes drilled in this area. So we have one borehole for every 42 meters, and somehow these boreholes are not anywhere near the perimeter of the building or near the excavation line. So these are basically at irrelevant locations. The irrelevant locations can actually give us a problem because of the variation in the strata is not known along the plot boundary. Now consider other case, it's a much bigger project where the perimeter of the plot was 1150, that is 1150 meters. 30 boreholes were drilled here, out of which 14 boreholes were more or less along the perimeter. Now here, one borehole for 85 meters each. The locations were relevant definitely, but they were very far too widely spaced. So these are two limitations. Now what happens is, in addition to this, like we have irrelevant test locations and insufficient number of boreholes, these two situations, but we also have insufficient laboratory testing. Supposing somebody drills a hole and tests only 2 or 3 samples of soil and maybe 1 sample of rock actually from each borehole, then the data available is very less. Similar, same thing is true of field testing. If you do not conduct expertise at regular interval, you would not know the variation of the shear strength along the depth. So, and the third thing, important thing is that the supervision team not informing the variation in the stratification during installation. These 3 things create difference in design parameters in and site conditions. The next important factor actually is the water table, water pressure. So during the investigation, we drill boreholes, as I said once again. In boreholes, you report water tables. You select a design water table based on that. Now, this water table actually one has to really account for monsoon variation. So rise in level during monsoon actually has to be considered. If that is not done, or if it is done, but then you get a sudden increase due to increase the water table because of flash rains, which is very common these days in this year particularly. You actually end up with few things like erosion of fines. It might cause piping because of sudden increase in the height. It can also cause soil boiling or sudden overloading. You can see on the left side, this wall is filled purely because of overloading. The ground has got saturated. The space in between was not enough, and the cantilever wall has simply given away. You see on the right side, there is a hole under the ground actually here. You can see clearly that the drain somewhere here must have broken, and the drain actually, the water flow actually has happened, and it created dynamic water pressure or dynamic load on this, and it created the same thing on the shoring system, and the shoring system has collapsed. Okay. Now, what are the other things? The other thing is surcharge. It's something we tend to sort of ignore or do not give that much of importance. But then surcharge, what we have found, is very, very critical. So active pressure generated because of surcharge load can be because of 2-3 different things. One is stacking of excavated spoils or construction materials by the side of the excavation line, and not here, anywhere here, but you can see the but it's a very normal thing, like people bring steel and store it there. Then adjacent structural foundations, the type and depth of the foundation. You can see on the right side, left side here, The left side building is very close to the property line and also close to the excavation line. Now this has got a footing. We do not what depth and how it is throwing load on this. That is at this moment not known to us. So it is very possible that the shoring system provided here in this slide is the top capping beam. Probably this is loaded with the footing loaded. Surcharge must be considered in such situations. On the other hand, on the right side, you can see this is a strutted excavation here. In this strutted excavation, there's an open space here. Now there's a clear-cut temptation to come and park some vehicle here. So vehicular load or construction equipment, because construction equipment will also keep coming to site. Like once again, I'm repeating, JCB will come, earth moving equipment, Pokering will come, different sizes of trucks will come. They'll bring materials, construction material like sand, cement, steel. Actually, will be brought and dumped there. Sometimes it is dropped, or not placed slowly, but it dropped to the direction. Dynamic load, kind of. So, and it's also possible that if this remains empty for some time and no work is done, somebody might plan to place something else here which is not thought of or planned. Okay. Now the passive pressure, the estimation of passive pressure is very importantly, passive pressure from soil and rock. Now here I would like you to really consider and look at this diagram and understand this slightly more than what we normally do, because we generally tend to ignore this part. The central point you can see here, the pressure at rest. When the retaining wall is standing and it is not moving, it is at zero deflection point and soil is filled up, then this is a condition where we have an at-rest condition, pressure at-rest condition. So it gives you some value, usually signified by 1 minus sine theta is considered as a K0. When the pile tends to rotate at bottom and move forward slightly at top, deflect at top, you will find that the pile moves and the wedge actually is formed. It tends to slide down, and because of that, even for a movement of 0.1% of the height, you will see that the active pressure is generated, and active pressure brings the pressure down very much on the wall. It reduces the pressure on the wall tremendously. So this might be something like 0.5 or 0.6. So it will come down to 0.3 or 0.33 or 0.3 or so. So what is important here is it requires the movement or deflection of delta, which is only equal to 0.1 times height. Now, but if you want to develop the passive pressure on the same soil, then I need to push against this wall. I have to push the soil back. If I'm trying to push the soil back, I actually face a lot of resistance, even from internal resistance from soil, because of which the passive pressure coefficients are very high. So you will see that the passive pressure tends to move forward, and it moves like a practically goes to infinity here. So we know very well that this is given by 1 minus sine theta divided by 1 plus sine theta, and it is inverse of that here. So this value is high. So if this is 0.33, this is 3. So, but then what interesting thing here is that the delta movement or the movement of the top head, which is required to be moved, is if it is 0.1%, in case of passive pressure, the movement required is 0.1%, or sorry, 1%. So 1% height of the return height is a fantastic amount for it to develop the entire passive pressure. So interestingly enough, for a what shall I say, the retaining system, which is reasonably rigid, it has got some moment of inertia of its own and rigidity of its own. So it will tend to initially move in a straight line like this. Now, when you are trying to get a value of say delta A for active pressure, really speaking, the full passive pressure would not have developed. So what happens is when delta P dash is equal to delta A, which both are equal because of rigidity of this thing, the maximum passive pressure developed on the way is P max divided by 2. So when you say Kp is equal to 1 plus theta divided by 1 minus sine theta, the actual pressure developed Pp dash at the time when both deflections are equal is only Pp by 2. Therefore, in the calculations, when we use factor of safety as 2 in our design calculations, actually you're using a factor of safety of 1 in reality. But in case of rock, the situation is different, and the allowable shear stress in the rock actually is used, or we tend to use that as a passive pressure directly. uh, more about this in next slide. So now, sorry, yes. But deflection of retaining system, this is also a very important factor. Now, what happens is the permissible deflection of retaining system, which is usually a cantilever, actually is as per Podol provision, you all know that it got some value X. Now, that is a pretty high value, but we know that for development of active pressure, it's only 0.1%. Now, these two things are totally different. So, but what happens is there is something in between. So, after the active pressure is completely developed, but it's tending to go towards the caudal side, you see that whatever is holding that soil, the material that is holding that soil, the structure above that, whatever is returned, the material which is retained, that has to have some serviceability criteria. It has some settlement tolerance, it has some deflection tolerance, and possibly it can absorb that. And if it is brittle, then you can see in the right side here, it is simply the soil has moved forward, the soil has gone down here, and there is a clear-cut separation line which is formed here. So such a thing will happen. Even serviceability of that upper pavement becomes important in such case. Same thing is true for serviceability of the storm water drains, maybe sewer gutters, or so many other things. So all these will become important as and when you get a deflection of the retaining system. So that also becomes a very important factor. Now the rock ledge. The risks which are associated with the rock ledge are like this. When the rock ledge is designed, basically, it is once again designed on a very little amount of data, very small sample of the entire soil. In reality, we'll see that during the excavation, that the grade of the weathering of the rock, you can see here, probably on the right side picture, the bigger, clear picture, that the grade of the weathering of the rock actually differs from point to point. It has got a different fracture frequency. The type of rock may not be different, but the type of rock is same, but the fracture frequency is different, and weathering grade is different. Now, what will happen is this, even the crushing strength will be different. So, the factor of safety of this retaining system, when you leave that this much of ledge here, suppose it's a standard ledge bench width, then it will be different at different locations. So during excavation, one must completely prevent overcutting of bench, and which will actually increase the risk and which can cause failure of the slope. Only if you're lucky, it will not happen. Now, these two things that are coming are basically not experienced in Mumbai. Heaving of clay. Like consider here that you are working in the alluvial soil deposit, and if we meet soft to medium stiff cohesive soil in the middle, clay in the middle here, and we excavate wide in the basement. These are the shore piles on both sides. Now, what happens is at the bottom of the shore pile, there is clearly gamma H as a surcharge which is acting on the sides, and we have removed the surcharge from here because of excavation. We have removed the water also by dewatering. So therefore, what will happen is this will tend to push the soil inside. If the SBC of this clay is less than gamma H, that is the overburden pressure here, then you see that there is a tendency of the clay to move inside and cause heaving. This can happen in case of over-consolidated clay on its own. Like supposing you just excavate this and remove the clay here and leave the over-consolidated clay in the exposed condition, it is possible that the over-consolidated clay can, even though this is not overcome, it will simply heave naturally. So we have to work against this. We have to make sure that this doesn't happen by increasing the embedment depth to sufficient value, so that the SBC of the clay which is inside the excavation is sufficient. A very similar thing happens in case of sand boiling. Let us say that we have excavated, actually done the shore piling, retaining piles are done, and you do excavation, but there is a water table inside, so you have removed water. You have put second piles all around, so water is not coming in through the retaining piles. So the moment there is a difference in water head, the seepage actually is set up. The process of seepage will starts. Now you can see clearly, or you can remember probably from your college days, that this will actually create exit gradient at this point. Now, if the embedment depth of this pile is not sufficient, this depth is not sufficient, then you will end up with an exit gradient close to critical value, which is 1. And if that happens, then this will end up with the boiling. This area will end up with the boiling. And the acidity of the soil will be totally lost. It will be a very messy condition. So unless or until we have enough water, enough depth of penetration here, one should not do excavation this way. So, but the heaving as well as the sand boiling conditions can be checked beforehand, and then before we meet them in a site actually. Now let us focus. Now this is all the points, different points in the design. Now let's go to supervision. Points to focus in supervision. 1 second. So we'll discuss the aspects of supervision of retrieval system. Now here what is important is that the supervision is a very key factor in successful execution and performance of retrieval system, because we normally don't employ educated and hardworking person there, and usually the normally situation becomes reversed. So what is the role and responsibility of site supervisor? He must understand drawings. He must understand the methodology of construction, pile as well as anchor installation, weather beam arrangement and fabrication. He should understand design conditions and applications during execution. You should ask them if he doesn't understand. And then if he finds that there's a variation as compared to design condition, it should immediately be reported back to PMC or through PMC to geotechnical engineer, architect and structural engineer, so that a proper coordination can take place. Now let us look at these aspects actually. Now, when you are supervising a pile installation, now what are the factors that come into picture? Let's look at them also. They are very important. Like first is pile verticality and alignment, fixing of temporary and permanent liners. So for this, we'll refer to next slide. You'll see that retaining pile have to be installed in a given alignment, and they have to be also installed vertical. Any error in installing the piles will mean that the pile might end up in the basement. And if the pile ends up in the basement, then you have to either chip the pile or you have to reduce the basement. Now, reducing the basement is not possible. So if that is not possible, then one generally ends up cutting the pile, basement actually. And if you cut the basement, then what will happen is you actually increasing the risk once again. The second factor is, like when we go back to the first slide again, we see the fixing of temporary or permanent liners. This we have seen as a common problem. We installing the casing at the location of the pile is very important before concreting, because till then the collapses can happen in the soil, particularly if the drilling or the boring is below the water table. We had experience at one site where insufficient length of temporary liner was temporary casing was provided, and when they provided insufficient temporary casing, the collapse happened in the soil layer because there is a water table. So the collapse kept on happening, and the continuity of the pile was always questionable. The integrity was compromised. So to make sure that the liners actually do the job properly, they have to be installed up to 4 strata. Then drilling to termination depth. Second part of the pile installation is to confirm whether the pile has reached the required depth. Now, this is very important in case of retaining systems, because we call them as a pile because the piling machinery is used to install the cantilever beam. And many times, what will happen is then when you're doing this work, the second part, the third part, drilling to termination depth, piling contractor will come back to us saying that, sir, this rock is very hard. I'm not able to drill to the required depth. Please give me concession and allow me to stop boring at a depth below specified. Now, it will involve correct identification of rock level also. In such case, if that happens and you are getting a hard rock, the material piles so sample is indeed actually very strong rock, then in that case, you have to change method of boring, method of drilling to higher capacity machine. Like we have very strong and big machines today, can use either them or you can use core barrel method to drill through that and go up to the required depth. But this is one factor, the embedment depth, required embedment depth cannot be compromised on. On the other hand, supposing instead of getting a hard strata, we get a very weak strata here, very poor strata here in this zone. And if that is not reported once again, even that can become risky by itself. Even both things, it works on both sides. Like very weak strata can make the thing unsafe also, and not being able to cut through the hard rock also will make it unsafe. So one has to be very careful about embedment depths. And on completion of the piling, like we can see that the auger actually is angular at bottom. So we need to clean the bottom thoroughly. If the bottom is not cleaned, muck will remain at the bottom. If the muck remains at bottom, the integrity of the piling will remain always in question. And if that remains in question, I think we require full fixity of pile in case of cantilever piles, and it may not function properly. One has to also pay a lot of attention to pile reinforcement, detailing, the curtailment, splicing, welding, also fixing the right sizes of core block to ensure that in the aggressive environment, the sufficient concrete cover is available to piles. Once you have completed and gone up to the bottom level, the third and most important factor actually is the concreting, because concreting usually in piling is done underwater. So Tremy method is used to carry out concreting from bottom towards top. Tremy is a small diameter pipe which will completely displace the muck and the secondary material inside the pile hole to the surface. It is usually called soil concrete or latons. If the concrete is not done properly, the pile shaft will not have enough strength. And if the pile shaft doesn't have enough strength, it would not act as a retaining system, and entire effort will be wasted. So the Tremy casing actually can be taken out of the pile only after the entire work is completed. Finally, on concreting the whole pile, the casing will be taken out. Now here, important factor is how much is the concrete consumption. The concrete consumption is a good clue to quality of concrete achieved. It means if the concrete goes in more quantities, that means there is somewhere there is a bulk formation or there is a concrete is flowing to some cavity. And if it is less, even that is a cause of concern, because is the squeezing happening, is the wasting happening, even that has to be checked and gone through. You can see a typical layout here. Typical installed pile with the pile tops are chipped and cleaned up. You can see, you will think, what is there in this? I mean, what is so great? We can see that this is done so shabbily. The piles are not in a straight line. The sizes are randomly less and more. They are inclined and tangled into each other. Probably the top cap is not placed properly. The double bars are not inserted and locked into the runner beam or capping beam properly. We had an event actually recently when one or two piles simply fell down. And the reason was that the dowel bars from the reinforcement were actually not engaged or not merged or not put into or locked properly into the capping beam. Now all this can happen at different sites. So very important part, supervisor actually is a must. So that person has to be qualified and that person has to pay maximum attention. He has to be very sincere. If that doesn't happen, then we really have trouble at site. There's a lot of risk. And all these things, though they appear very small, individually can cause failure of pile. If the failure of pile happens, then our retaining system does not function smoothly at all. Now we'll look at the next factor, tieback anchors and installations. Now we have seen how the tieback anchors are very important. Now you know very well that the anchor's location is selected, you excavate up to particular depth, and you excavate up to particular depth, and then you drill a hole in incline. Now, when you drill a hole in incline and you use high strength deformed bars, these are very strong bars where the Fy value, the yield strength value of the steel is as much as 1850 newtons per millimeter square as compared to our normal Fe 500. They are and they are there in strands. So when they are in tension, they are subjected to stress corrosion. We know all of that. So the most very important thing is the quality of the strands has to be checked repeatedly and immediately on reaching site. Any spurious branded steel should not be purchased. Only the standard material should be purchased. This has to be checked rigorously and thoroughly by supervisor. So anchor material quality, then is checked. Then the second thing is are you drilling the hole of given diameter? Supposing this drawing specifies 6-inch diameter hole, that is a 158 mm diameter hole, then has used the correct size bit. Is the length of the anchor sufficiently drilled, properly drilled? Is the sufficient length gone into the hard rock? Now the third point would be, are we consuming cementitious or high strength grout into the fixed length? Is the quantity enough? After consuming and grouting, you make a check on the depth of the set material to ensure that the right amount of or a right kind of fixed length is achieved, because fixed length is very important, because when you stress actually after 21 days or after 7 days, it actually acts like a anchor block at the other end. Then so the achieving correct length, correct penetration, good stratum becomes very important. Now the second component here is the weather beam or waller beam. The fabrication of the waller beam or weather beam becomes also very important. Because this has got a skew shape or skew look. To understand this drawing is a major issue actually. The detail of the drawing, which is drawn by us or by anybody else, is not at all understood clearly or safely, completely, and the drawing is not read properly. It's a very important part. The second part here in this is that when you fix the curved plate onto and the bracket plate onto the each and every pile, you actually have to use what you call the anchor bolts. The anchor bolts, anchor bolt is a different story. So first thing is that curved plate and bracket plates have to be fixed onto each and every pile. That is must, because if that doesn't happen, then force from each and every pile will not get transferred to the weather beam. One. Second thing is, when you use right kind of and right length of the anchor bolts to drill through the plate and into the rock concrete, it must not remain in the cover of the pile. It should actually enter the core of the pile, very core component of the pile. So even that is very important. So anchor bolt quality and anchor bolt length also are very important. And then while fabricating, what we have seen many times is the bottom plate and top plate are fixed and they are left in place and only spot welding is done. Sufficient number of stiffeners are not provided. Their stiffeners are not welded to full length. The main bracket plate is also not welded completely. When we go to site, we are told always that, sir, that is just, I set it up and now go to weld it. Now, supervisor at site, that's why becomes very important. He has to make sure that the welding is being done with the correct size of rod and to the correct length, to make sure that the load transfer from the anchor to the girder to bracket plate to pile takes place. If that doesn't happen, then the failures of the rotary system are very easily possible, because this is the joint, this is the connection, and the connection is not proper. You will find that the thing can fail completely. The next is tracing of the tieback anchor. In the stressing of tie back anchor, you can see here that there is a plate at top and then there is a plate. These are called thrust plate and this is called a bearing plate. Then there are wedges which are fitted into this actually. Now, all these three materials has to have a proper grid of steel. It should be able to carry the forces in bearing. But typically for wedges, high grade steel, that is a EN32 is actually preferred. And for the bearing plates, the circular bearing plates, we actually require at least EN8. So these details are very useful, and because in that case, then what happens is then it doesn't get corroded very quickly and it remains locked in place. It is not affected by the changes in the stresses also. So this is very important that you provide these plates also in a correct manner. Now, while stressing the anchors, we should be able to calculate. Say we know how much is the free length because you have taken a grout measurement. Now there is the amount of the free length. So the free length actually there's a standard formula, Hooke's law, which will tell you that for a given load, when you're applying on each pile or each strand, each strand is going to get elongated by theoretical calculations up to a certain value. Let us say that value is some X value, say 5 mm, 6 mm, 8 mm, 10 mm, whatever it is per meter. Now for that value, if that value is not achieved or there's a tremendous variation within the given strands here, let's say there are 10 strands here. In the 10 strands, you have 10 different elongations. Then something is seriously wrong. So we really have to look at that factor also very carefully. So elongation measurement has become very important. And finally, deflection of weather beam. The deflection of weather beam means the weather beam itself can move backwards while stressing. But then under different conditions, when the soil gets loaded or because of unknown forces or this thing, if the entire system moves forward, then that has to be monitored very closely. Now, how to do that? So, sir, how much time do I have now? Sir?
20 minutes. 20.
Good. So, all this actually will matter, and we leave the deflection of we have to monitor all of them. The computation of elongation, required load or pressure gauge readings are not understood correctly. During the stressing, elongation has to be recorded for each and every strand. Slippage of strand also has to be checked and noted. Sometimes the weather beam tends to move back. It should be recorded. The movement of the pile heads and waller beams has to be monitored with the total station at a regular interval till construction reaches plinth level. This is also very important. Then I'll skip this slide, go to the next one. The stage construction. In the stage construction, we are going to see typically the anchor is first connected and then anchor is then released with the time. So let us say in the stage 1, we have original ground condition. Then we come to site, we select an alignment and we install returning pile here. We have installed a returning pile in place. Then we know very well that we have an anchoring level, so we excavate. So this side is opened up, the pile will deflect out slightly outside. So then we go to the next slide and see that we put an anchor here, and when the anchor is stressed, there is a tendency for pile to move back. And probably the deflected shape of the pile will be somewhat like this. So the head would then move back because the anchor force actually is much more than what is the active pressure, what is initially there. If you see the previous slide, whatever active pressure is there, that value is, let's say, X, but then you are going to put passive anchoring force, which is much bigger than that. So it will tend to move back this way and form a deflection curve this way. And then you excavate further, go up to the excavation level as shown on the right side. Once you have gone to this level, this will once again tend to move forward like this way because of the this way, and you will see Then you start constructing when you start constructing this thing, and you come up to the bottom of the anchor. Usually you select a anchor level strategically in such a way that it is just above the slab. So you construct the slab here, place the slab here, fill the gap in between using concrete, so that this is the pile movement is then locked, and then release the anchor. So we are achieving the this situation once again. So once again this is done, then you will find that the pile, returning pile actually can be released, and the anchors are taken out, waller beams can be also taken out, and they are actually disposed of. So what is the summary? The summary would be that design and site conditions are totally interdependent. They cannot exist by themselves separately. And supervision is a very critical thing for closely for monitoring the situation. And if that is not done, then failure can happen because of the negligence at various intermediate stages. I'm sorry. The second important part is during the execution, whatever design assumptions have been made, they have to be validated. In the sense that supposing you said that rock is at 5 meter depth, 3 meter depth, 2 meter depth, that has to be actually verified and validated during the construction. And if that is not done, once again, if there is a variation not reported, then there is a problem. Usually, while selecting a threading system for a given site, which is technically correct and safe both. So this is usually a tailor-made situation. You cannot actually have take a situation. I have designed one threading system for site A. I cannot lift it and place it on site B and say this is directly applicable there. So it is very rarely so, because steel would be different, bending moments would be different, everything would be different. So for each and every site, the threading system would be tailor-made. The most important part here is it is necessary to educate and provide guidance to the field supervisors and engineers who are monitoring the work, carrying out the work in field, whether they are engineers and supervisors from the contractor side, or from the client side, or from PMC engineers. All of them actually have to know. They have to really the fulcrum of the entire execution is the supervisors. They are a key element and key point. If they are not aware of the things, if they make mistake, they don't report, they neglect, they don't look at any part or overlook something or allow something in their own knowledge that this can be done, then the real problem, because whatever decision is taken without knowledge of geotechnical engineer may become a difficult situation at later point of time. Now, how to ensure that this doesn't happen? So our proposal is that a checklist has to be issued with the when the person comes to understand drawing, understand the design assumptions, understand what has gone into design. He has to actually visit or come have one dialogue with the geotechnical engineer, decide, understand what are the bare minimum important crucial points he must not miss. So a checklist for each component of a training scheme has to be prepared and shared with the client, possibly with the PMC team and with the supervising engineers at site. And once that is done, then following that list carefully will help actually in ensuring the safety and mitigating the risk of the training system. Now, all this actually will involve proper coordination, means because ultimately everybody is sitting on the same side of the table, be it a contractor or project monitoring consultant, geotechnical consultant, structural consultants, or architects. In the rising hierarchy, I have written down the names. I can see that though everybody plays their important role in the situation, they are the members of the team, and if the coordination is not there, and if any one of them do not perform their task correctly, then you will see that the rating system will not probably perform as desired. So with this, I would like to thank the EFC again and stop my discussion. Thank you. Hello.
Yeah, thank you, sir. We now put this session open for question and answers. All are requested to write their question and answers in the QA box. I will take it one by one. Meanwhile, I'll ask the first question to start with, so that people will get some time to write the questions. I just wanted to ask, while doing equilibrium calculations to fix embedment depth, that is
Yes.
sigma m equal to 0 calculations, we are, I don't know, but full active and passive pressure are considered, whatever they are, with 1 minus with
Correct,
the
sir.
phi value, correct? But you also said that passive pressure doesn't develop unless required deflection is achieved.
Yes.
But these two are different calculations are done, or when then how the embedment calculations are validated without deflection calculations?
Understood.
How to consider this in equilibrium calculations?
Understood. Yes. So what is assumed actually is that the full passive pressure is actually not achieved. You actually have considered half the passive pressure is achieved.
How
Or
particular?
that is what you do is the stabilizing bending moments or stabilizing bending moments are generated because of passive pressure, or they are possible because of passive pressure.
Correct.
And passive pressure you divide by 2. So when you are actually balancing them, you take a factor of 2 there. So stabilizing divided by destabilizing, the ratio has to be minimum 2.
Okay.
Once that
But
ratio
that is a factor of safety, no? That is
No,
over
sir,
and
no,
above
sir.
this. No.
No. I said at that time also the effective factor of safety at that time is only 1. So what we do is we actually increase the length of the embedment by 15 to 20%.
Okay, take care of that.
Yes.
But actual deflection calculations are not done in the equilibrium calculation.
Not by hand calculations, but if you use softwares, they are definitely available.
Achha, there we can do that. Okay.
Yes.
Okay, fine. We'll take the questions now. I'll read out the questions. Meanwhile, people can still write. First is how is reverse cantilever wall from Mr. Ishwar Thapa? How is reverse cantilever wall construction process carried out?
Yes, correct. Okay, we had a situation, probably I can explain. We had a situation in Times of India building in Kandivali, where we actually employed this reverse cantilever in real life. What had happened there was that there was some fragments on the other side of the plot actually, and we had our retaining wall or the compound wall in place. The compound wall actually had got damaged actually. The mortar in the compound wall actually had completely probably got washed out, and it was removed maybe partially also. Some stones were removed and everything. So the thing that wall was in dilapidated condition. So in that case, it was not possible to provide sealant to the at all. So what we did there was we actually put a new skin wall along the existing compound wall of 200 mm thickness. Then we actually had a base slab at the bottom, and to ensure that both are this new wall is stable and it can take load from the other side, we actually did anchors actually at standard interval of 1 meter or 1.5 meter along the length of the pipe. So the stability of the wall was ensured, and we actually installed a reverse cantilever in practice. This we did actually physically. You got it?
Yeah.
Yes.
I think yes. Next question is from Vidula Prasad. After how many days of capping beam casted excavation work starts? Meaning, what is the structural action to be considered for capping beam?
Capping beam actually doesn't in normal course. The capping beam, there is zero force actually acting actually at the capping beam. Frankly speaking, the lateral force acting there is nothing. So probably we can start the excavation within after 7 days, because at least then 2/3 strength would be there in place, and whatever incidental load will come at that time, it can take.
Okay. That way, capping beam doesn't play any structural action.
It actually is like a human chain. Like it actually holds all the beams together. I just told you that 2 piles fell down because the dowel bars are not actually inserted into pile cap and not merged and concreted together. They are simply standing. The piles are standing, so only 2 piles fell down. In one situation, I explained to you.
Yeah. Then there is next question is from Mr. PV. In some surface references, deflection values for active pressure are available. But are there any specific deflection values for various soils to achieve passive pressure?
Yes, that is there. Like reference deflection values for active pressure are 0.1% for this thing, non-cohesive soil, that is the sand, and in case of cohesive soil, they are as much as 0.5%. So for the clay soil, that value is much higher. And when you're trying to develop a passive pressure, the as I said, that 1% is a deflection for passive pressure, which is very high. But then in case of this thing, it's much lower, much lesser. Sorry, in case of clays, it is nearer 2%.
To develop full passive pressure.
Yes.
Yeah. Next is from Mr. Tushar Natushkar. Which software you suggest for this design process?
Many softwares are actually available, but Wallop is one of the commonly used software these days. Wallop.
Next is from Mr. Vaishak Nair. Sir, is it advisable to do piling when water table is too high, as it is difficult to control verticality of piling?
Okay, I mean, possibly, okay, I can understand you are a student.
Yeah.
Water table is high in many places. Like you go to places like UP or North India, where water table is very close to surface. So in such case, then piling cannot be done at all. No, that is not so. The direct mud circulation method and or permanent liner method, both are actually used to prevent collapse of the pile hole completely, and you can carry out the verticality of pile can be maintained. If you know what is the direct mud circulation process, I would request you to read this process, direct mud circulation process, that is a bentonite mud circulation, and you will immediately understand how the verticality can be maintained.
Yeah, thank you. Next is from Mr. Tushar Natushkar. How can we decide the inserted tendon capacity and friction on soil behavior? How can we decide this? Yeah, how can we decide? Maybe how can we ensure maybe how that inserted? I couldn't understand. Mr. Tushar, can you elaborate on the question further? Then I can ask that. In a next is Mr. PV. In a rock mass, is allowable shear stress can alone be taken as acting pressure on both sides?
No. See, normally what happens is rock mass has something that is called the total stand-up time. Rock mass doesn't fall down immediately. Like when you pass by so many ghats, actually Western Ghat or any other places, you will see that the rock surface is standing freely vertically for a certain amount of time, and that time can be from 5 minutes to some years. So depending on the quality of rock mass, the rock mass could be standing there. But then supposing because the pile tends to deflect and bears on the rock mass, actually the shear force or the shear is actually taken. The allowable shear is taken as acting pressure only on the passive side. On the active side, the pressure thrown by rock would be zero. If you are going to be very careful, like some of these European codes are, then for very highly fractured rocks, they actually allow some pressure to be taken even on that as an active pressure also.
Thank you. Next is from Mr. Sachin Borse. What are the signs before failure of retaining system so we can prevent failure?
Very tough. The soil failures actually are always associated with the large deformations. So the prevention of failure would be primarily where the water is seeping out. Is the water becoming turbid? Is the water are you getting clean water throughout? Let's say the water is flowing out. Are we getting a clean water throughout? That is one of the key elements. If that water is not turbid, then there is a chance that the water is good, no failure will happen. But the water turns turbid, then there is a first sign that probably there is something wrong in the retention scheme, and one should actually get alarm and probably do something that is required to be done so that can be prevented. And as I said earlier, also we should monitor the pile heads and boiler beams regularly on a daily basis or a weekly basis or some kind of basis, some time interval, so that we can actually have note the movement of the returning system from their zero position or from their datum position. Once that is known, then we can have some kind of sign there.
Yes, thank you.
For the what should be ratio?
Ratio of bore numbers to area under exploration.
Yes, we actually prefer. See, you can. I mean, this question is very generalized, but then will not be liked by the clients and the developers. The number of boreholes, what we do for the main structure of tower should be different. The structure, the bores, what we should do for the shoring system should be different. Their requirements and their requirements of both are totally different. If the bores are, if somebody permits you or allows you to do bores even along the shore pile alignment, then they should be at roughly at every 30 to 35 meter interval. That is a minimum. If you can go closer than that, super.
Next is from Vidula Prasad. Can we make some degree inclined pipes outside, like excavation side? It's inclined system, maybe.
Inclined piles, man, sir.
Yeah, inclined pipes must be.
The space is not there.
Mm.
So most of the times the space is so low, they probably will not be able to do anything. If you are within 1.5 meter and your diameter of pile is say, let's say 600 or 700 mm, what degree will you take? Very difficult to do anything there. Plus, you require something like 750 millimeter from the compound wall to carry out the work. So, because of machinery limitations.
Yeah.
So, inclined piles are very tough to carry out. I'm considering that as an inclined pile, not as a pipe.
Next is Tushar Natuskar. How to calculate the anchorage length of tendon in soil?
Yeah, okay. Textbooks are available for this, but then you have the phi value of the soil, given soil. That will actually help you in calculating the anchorage length. You know very well that tau is equal to C plus sigma tan phi. So that equation you can use, and you can get the friction coefficient, I mean the shear stress, and you can calculate anchorage length. Sigma tau is equal to sigma tan C plus sigma tan phi. This equation can be used at a given depth.
Thanks. I think that is the end of the questions. I think we have still 5-10 minutes. We can, if anybody wants to ask question, I'll wait for 1 or 2 minutes, and then otherwise we'll proceed to the next. Or you can ask at the end of the session also. We can yeah. We can. So we proceed further. Yeah.
Now I'll introduce our next speaker, Mr. Abhijit Kulkarni, who is ME Structures in 1995 from VZTI, BE Civil from SPC. He is Fellow of Institution of Engineers, India, Fellow of Indian Association of Structures Engineers, Member of Engineer Australia, Chartered Engineer UK, Australia, India. And its countries of projects is UAE, Saudi Arabia, Oman, Qatar, UK, Kazakhstan, Libya, and India. He worked with Stu Baptiste, Hyder Consulting, YT Bird, Ramboll, and Bureau Happold. His current position is Country Director Structures in Bureau Happold. Now I request Abhijit sir to start with the lecture. Thank you.
Well, thank you for giving me time. Can you hear me well? Veronica sir, can you hear me well?
Yes, sir, we can hear you.
Okay, okay. Give me a sec, let me just share my screen. I hope my screen is visible.
Yes.
Okay, so good evening, everybody, and thanks for giving me this opportunity to talk about soil structure retention system, mostly from structure engineer's perspective. And thanks CFC for giving me this time slot. Now, I'm not going to list too much on shoring system because Mr. Vashampayan has already discussed significantly on that, but I'll just run through that. But what is critical for this particular presentation is structure engineering considerations and what may go wrong that may have impact on the project. Let's go to quickly the shoring system. I think this has already been discussed. You have sheet piles, you have soldier piles, which is I sections, height sections with planks. Then you have contic piles, secant piles, and diaphragm walls. So Vashampayan has already discussed. And then there are, given project, there will be combinations of these depending on type of rock, depending on type of soil conditions, surcharge, groundwater conditions, and so on and so forth. I will skip that. Because I'm skipping it just because we have discussed it a lot and don't want to bore people. This, if you see the bottom right there, that's generally being used to use in Middle East, that how you align your construction of piles at the grade level. So you cast this kind of a guide wall with the thermocol inside. And once you cast the guide wall, you remove the thermocol, that gives you some sort of a circular interventions. And then through that, you put in your sleeves or you put in your augers and then try to drill the piles in a vertical direction. Yes, there are challenges in keeping the verticality, but then there are codal provisions, and I'll come to that later date, later time presentation on what are the tolerances. I think we discussed about methodology. So basically, you drill this guide wall, then you cast this guide wall, then you drill in, and then depending on your soil conditions, you put bentonite or soil retention fluid for the borehole, and then you put a creamy, and then you cast from bottom. And then you do that repetitively, depending on which type of system you have, whether it is contig wall or secant wall. And then you have a diaphragm walls, which is more or less all these are top-down constructions, and diaphragm wall is probably the more difficult portion of it, or difficult type of construction. Mainly because when you have diaphragm walls, you tend to have deeper excavations, and that's the reason why you go for diaphragm walls. And you also tend to have water resistance or water retention loads on the diaphragm wall. So the panels, the cage that you are installing becomes heavy, and then that's how it becomes a bit tricky and in execution. And the gaps between the two diaphragm wall panels become more of a areas where the soil or water can leak. And that's why the installation process has to be absolutely spot on. And then, as I said, there are combinations being used, and sometimes you have diaphragm wall with secant wall. I mean, on the right side here, you have one of the projects in Dubai. We had 6 basements, and the perimeter was completely diaphragm wall. But on one of the sides, let me just see whether I can show my cursor. Let's see. Just can somebody see my cursor moving here?
Yes, sir. Yes, sir.
Okay, good. So on the other side of this, there was a marina, Dubai Marina. So it's basically a seawater which has pulled in to create a marina. And then that water was about 15 meters deep. So we could not physically go and excavate next to that water, although we had a marina walkway around it. So what we did there was constructed an internal wall about 10-15 meters away from the marina wall. So we had a diaphragm wall all around the plot. We constructed the internal wall, which was again not a diaphragm wall, so it's a combination of it. This was anchored, and the main structure was constructed, and then the main structure was used to strut, to resist the struts for this permanent diaphragm wall, and the second stage construction was carried out. Whereas on the left here, you see there are these H-beams or I sections being installed on capping beam. Now, this is because the current groundwater table, ground level was lower than the permanent ground level what the development was supposed to have. So they were expected to backfill this whilst we were constructing inside. So we said that let's not start our diaphragm wall or our shoring system from this level because that's expensive. So we started from lower level, and then we put this projecting H beams, which were designed as cantilever to resist the backfill as and when it came. So it's basically it was more of a combination of things. And then just quick references to what I've been doing, and we have been utilizing the type of systems based on height of retention. So invariably, when we do this in Indian conditions or in property sector condition, you will see that we are excavating probably 2 basements, 3 basements. So the rough order of magnitude of excavation would be in the range of say 8 meter to 10 meter, and then sometimes could go all the way to 20 meters. And then depending on the surrounding, depending on the availability of machinery, you would have a different shoring system being implied. And then you can either strut that from inside if you have restrictions to put anchors. Sometimes these restrictions are put by authorities. Sometimes the restrictions are put by adjacent owners that you can't go underneath of their foundations. So you have to, when we plan it, you have to plan it thoroughly, saying that these are the constraints and we work within those constraints. Now let's now talk about some structure engineering considerations. Now, what is needed for a construction of deep basement? Obviously, we all know that size and shape of the site is critical. We all know that. Volume of work in terms of how many basements and what sort of soil we have. So how much time it's going to take in terms of excavation, in terms of removing the muck. And that will decide a lot on the amount of time that the shoring system has to be operational. And when I say operational, once you construct the basement, you are expected that basement retaining wall to take all the loads, and the shoring system then becomes more like null and void. Provided it is not designed as permanent structure. There are solutions for that as well. But if normally it is designed as temporary structure, so a volume of work will dictate how long the shoring system has to be operational. And then topography condition, depending on normally buildings in city limits, you will have a reasonable topography, but there are chances that you will have a big site and topography will vary. On one side, you will have hill, other side, you will have valley, and then you will have water flowing in that direction. So you got to be careful about how the topography works with. Then neighboring condition, as I said, there are roads around the plots, there are adjacent buildings. Some buildings might be recent, some buildings might be old. We don't know sometimes the foundations of the existing buildings there, so we've got to be careful there. On one of the projects that we are currently working on in Bengaluru, we had to construct a retaining wall, and then the adjacent society had employed an independent consultant to review our design, despite we giving us a validation. So it happens that people are, they're putting their lifelong savings into these apartments. So they definitely want to ensure that your construction is not going to affect their livelihood or their income, their residences and their flats and apartments. In addition to that, you have surroundings services. Sometimes services are critical services, maybe a gas pipeline, maybe a water supply pipeline for a bigger area, maybe a sewer line which is coming upstream, and then it's a gravity line, and then you have challenges in terms of if you break that, then what if so it becomes a bit of an headache for authorities, headache for your own plot, your contractors. So you got to be careful about that. And then geotechnical conditions, as Mr. Vaishnapan said, that it varies from between the site also. It might vary, rock conditions might vary, your soil conditions might vary. So one has to be careful about when we are designing this. We are considering the appropriate condition, and adequate number of borers have been dug, adequate number of borers have been dug to get the sufficient data of the surrounding sites. Internal layout of basements and other structure also is related, mainly because when we are doing such type of excavations, you will invariably have shoring system, you will have dewatering systems. And then when you are employed dewatering system, don't want to have the well point bang below your columns or walls. So internal layout is also critical when you are planning some sort of a deep basement construction or activity. And again, it boils down to availability of expertise of skilled contractor. Sometimes the machinery may not be available. You might have probably 4 or 5 contractors who could do only piling operations, so you can be a competitive bidding. Whereas you have only maybe 1, maybe 2 contractors who could do diaphragm wall, and you'll end up probably paying that premium, being limited number of contractors. And another important aspect to be considered is the waterproofing for the main structure. Now, we are talking about all this shoring system being temporary, and then removal of anchors, struts, and other stuff. But when we construct these systems, imagine that you are going to construct your main structure against it, and that main structure has to be protected from underground, groundwater table, or maybe your salinity of the soil. So there, the waterproofing system for the basement has to be kind of a tanking system, and installation of that system requires certain smoothness or certain flatness into the shoring system. So when you are doing a pile wall, perhaps if you are going for some sort of say bonded HDP membrane, or maybe going for say PVC membrane, you may not be able to install it unless you put in some sort of a screed or some sort of a graniting, or maybe a PVC plywood shuttering in front of this shoring system to have a clean and flat surface to install your shoring system. So all these aspects come one way or other influence the type of retention system. From structure engineering perspective, obviously there are geotechnical requirements, but from structure engineering perspective, for the main structure, all these aspects will come in place. And then from construction perspective, sometimes, most of the time we do say bottom-up construction. Either you do open cut on the shoring, or you have a shoring system installed. But sometimes you have top-down constructions as well. And when you have top-down constructions, the shoring sometimes, or when you are top-down, mostly top-down construction, it would be considered as permanent structure. So there, the quality of concrete, because your temporary structure would be, design life might be around 5 years, but your permanent structure, you'll have a design life of 50 years. So you got to be careful about the quality of that top-down construction diaphragm wall. Mostly it will be a diaphragm wall if you are doing top-down construction. So it acts as a permanent retaining wall in the main structure. Then what is critical from structure engineering perspective is when you are constructing something in deep basement, what is there at the site? If it's a barren land and you are constructing fresh, fantastic. There is nothing obstructing you. But then if there are structures on that land and that needs to be demolished, and those structures have some basements, then things become a bit interesting and a bit complicated. And then depending on the extent of those basements, existing building might have 2 basements and you are going for 3 basements or 4 basements. And then the existing building might have already had some sort of shoring system installed long time ago, which is sitting there dead, and then you are going to demolish it and start excavating. So it then becomes a challenge on its own, because depending on the location of this existing shorings or existing buildings, your construction activity would have to be tweaked, you have to be modified, and that will have invariably impact on the new construction and new shoring system that you would like to install. So construction stages, whether it is demolition, whether it's a renewing stage, or whether it's main works, one way or other they are linked. So when we are planning some sort of a basement construction, these aspects needs to be considered, and then impact of these aspects onto the shoring system has to be considered. I'll show you maybe a couple of slides further down the line. I'll show you what happened for one of my projects. Oh yeah, here it is. Then clarity of thoughts from structural engineer. Right? Depending on when you visit the site and you know that certain things have to be built, the structural engineer should start thinking as how am I going to build it. Right? It's not to be left with anybody else. Architect is not going to tell you, or client is not going to tell you. Right? It's a structural engineer who will then dictate, saying, okay, I have to go down these many levels. Then I need to protect all 4 sides, 2 sides, 3 sides, whatever. I need to have some sort of stability for roads or surrounding buildings. Obviously, geotechnical engineer will be part of this, but geotechnical engineer would be looking into more details of these retention systems and coming up with options, carrying out analysis. But if you really look at it from the constructivity perspective, before even contractor comes on board, a structural engineer should have clarity of thought. At least one way of construction has to be there, thought through, so that when the tender goes out, your contractors don't come back and say it's not constructible. So the structural engineer has to have a clarity of thought in terms of how am I going to do it. Right? It could be simple sketches, it could be some PowerPoint presentations, it could be some report. And then depending on the complexity of the project, obviously, your clarity of thoughts will vary. There will be influencing parameters in terms of time. Some of the existing buildings might be occupied by end users, so they have to be vacated and demolished. All those aspects come in place when we talk about clarity of thoughts. And then comes the selection of the shoring wall system. It is again, this is not the structural engineer's decision, but structural engineer can influence in a way based on what is needed for the main structure. Because when all this is happening, because our clients, the developers, they want to construct something which can bring them revenue. And when we say construct something, there are area calculations defined, there are some revenue calculations defined, and invariably there are limitations on all these aspects put in together on the construction methodology. And that's why it is critical that an appropriate shoring system, which is suitable from the client's perspective and suitable from obviously geotechnical and site safety perspective, has to be looked into. You could do anchoring if you are allowed to do. If you are not allowed to do anchoring, then you have to go for some sort of internal struts. Again, internal struts have knock-on effect on the speed of construction. So you have to find out up to what level, up to what spacing the internal struts can be. And then I'll come to that later on the internal struts. And then you can talk about the stage construction I just explained on one of the projects in Dubai. When we talk about anchors, obviously, Mr. Vashampan has explained about how these are stressed and what sort of forces, 1850 or 1800 MPa sort of strands, and then they are stressed. And then there are calculations, there is Balap, there is reward, there is OSs, there's fluxes, there's so many, and then there are spreadsheets for calculating tendon lengths and anchorage lengths. But at the same time, what is also critical is, where you are anchoring. Now, the images in the center, you see there, the top the image was anchored underneath of Dubai Marina, one of the plots, and you can see this on YouTube. Search on, I think it's Infinity Tower Collapse 2007. So they anchored below Marina, and then on one fine day, they started seeing that the water is oozing out of the anchors, although they were grouted anchors. And then obviously they notified that there's something wrong. And within about 2 to 3 minutes, all these anchors just zipped up, one after another, they just zipped up. The entire retaining wall, the diaphragm wall, which was about 900 thick, just collapsed the way you see there at the bottom, and the entire seawater gushed into the plot. Now, they say that nothing happened in terms of loss of human life, but certainly there was significant loss on time, significant loss of machinery, and then all the nitty-gritties, insurances of the construction went up. The construction itself became delayed. It had knock-on effect on other parts of the construction in that area. Suddenly media came in picture, and they started saying that this rushed construction, Dubai is causing this issue, so Dubai has to slow down. So it kind of blown out of proportion. Yes, it was a failure. Yes, it was a technical flaw. But when certain things happen, it becomes so difficult to control it, especially when it goes to media. And that's why I keep talking to our guys like consequences of losses or consequences of mistakes in, say, geotechnical and structural engineering are so high, so heavy, that fixing that becomes a challenge on its own. You might have, maybe your duct size might be different. Sometimes in HVAC system, you might have some issues in your bus bars in electrical systems, and that can be fixed because it's highly technical side, and people who are controlling it, they are highly technical. Whereas here, it is visible. It is, any failure of this sort, whether it's structure or geotechnical or combination, it is visible to local public. And then how they interpret it in media, it's absolutely, no control whatsoever. So that's why it is critical that we learn from these mistakes and we don't do it. We don't repeat it. So I was talking about this clarity of thoughts and anchors. So this was one of the project along that Dubai Marina, and this was an existing yacht club, which was about 15 years old, nicely done, blue lamp timber, and then it was one of the key structure in that area. But obviously, that area was pretty premium, and then the developer said that, okay, I'm going to demolish this existing yacht club, and I'm going to put in a hotel building which has its own yacht club. So I'm rehousing that yacht club in a hotel, and then the residences above that. So the top left you see there is the basement extent of the yacht club, which is about 2 basements deep. And then we were for the new hotel. And then for the new residences, it needed to go to 4 basements deep. So effectively, we had to extend the existing, almost entire plot was basement. So we had to demolish that and then extend it for the 2 levels below the existing level. So, but then when the existing building was demolished, we realized that when they constructed the basement, they used second pile wall. And then demolition of the second pile wall was not possible because there was the road adjacent to that. If you see on the top right here, is my cursor visible?
Yes.
Yeah. So if you see here, there's an existing road, so we could not demolish anything. So we then said that fine. So we have to make use of it. Although it was old, but quality of concrete was not that bad. 10, 15 years. Okay, anchors were completely gone because they were not meant for that sort of a duration anyway. So we re-anchored this particular retaining wall or temporary shoring system, and we excavated down to that level. And then when we started further, we installed another level of shoring anchors, another level of shoring system inside the plot. And thankfully, in this case, we had that space inside the plot. So we put in another layer of diaphragm walls, which you see here, and then the shoring all around that was a diaphragm wall. And then that diaphragm wall was then anchored between the 2 sides. This side we were at a lower level because there was two floor level difference between the roadside as well as the marina side. This was the marina, and there were two levels difference. So this side was more or less freestanding. Diaphragm wall was good enough because we couldn't drill or hold down or anchor below the marina because of the failure of the other plot. So in the middle portion, which was pretty high in terms of excavation, as well as there was not enough space for putting this diaphragm wall, thick diaphragm wall to act as a cantilever, we went for struts. And then it kind of ended up something like that. So you see here, the way marina here, the road here, and then we had struts and we had this one level of anchor you see here along this line. And then there was a strut at the center and anchors on that side. And when we did this internal strut, obviously there's, as Mr. Vashapan said, that it's absolutely critical that we identify what level these struts have to go, because below these struts, you are still having some sort of excavation and construction activity, right? So there was a raft being constructed. There's a 50-story building to be built through that strut. So we had to plan these struts in such a way that they are not obstructing the construction of the core walls. They are not obstructing construction of the raft and the basement slabs. And then we also identified at what time the struts have to be removed so that the main structure with the foundation and one level of basement is good enough to take the forces. So that means the strut levels were identified based on that. Strut positions were identified based on the location of the core wall. And again, although this is all geotechnical, it has influence from structural engineers' perspective. All this, toing and froing between the geotechnical engineer, the contractor, the engineering works contractor, the main works contractor, and the structural engineer, it is all collaborative effort. Otherwise, it becomes so difficult to manage these sort of complex construction activities. So this was, if you see the top here, that was the site which was collapsed. Water came in, so eventually got fixed in that manner. Again, this was not our plot. Our plot was here, and we came to know about this because our plot was considered as the mass against which these struts were laid. So we went in there and we said that, okay, we want to construct this building. Obviously, these struts have to be removed because the moment we start excavating in our plot, these struts will become null and void. And then that means the support that they were supposed to give to that part of the soil would be lost, and then there will be another collapse. So there was discussions between the client, we were working for them at that time, and then this Infinity Tower came properties. There were discussions about when the struts will be removed, what would happen when the struts are removed from one side, how the shoring system can be utilized, because they had put in a diaphragm all along here. And there was no need, because once this was 6 basement, this was 6 basement. So once they had constructed, the permanent structure was constructed, this diaphragm wall was standing freely between the two retaining walls. So we said that, okay, we give you some sort of leeway in terms of time to construct your structure, and we will work within that time to put in our shoring system, to work out our design. And then once we come on site, you would be constructing all this and come up to ground level so that you can remove the struts and you can go excavation. And this was carefully planned between the two clients, between the two construction team, two contractors, the two structural consultants and geotechnical consultants, so that there is nothing which was sort of overriding each other. And again, this requires a lot of convincing. People don't agree sometimes. People feel that what they have done is correct. I mean, the first reaction when I went in there and discussed this is, we are started inside our plot, and then you can do whatever you want to do in your plot because we are not obstructing your plot. So it started from that sort of a discussion. And then when we started explaining them, then saying that if we start excavation, your struts are going to collapse and your entire shoring system is going to collapse. This is when it all started becoming more and more intense. And whether it was permitted to put those struts against the soil, whether the struts were designed for the excavation. The shoring system was designed for this sort of excavation on the other side. So all these dialogues happened, and then eventually both the clients agreed that, look, in the best interest of both the projects, let's work together in collaborative manner so that both the towers are constructed now. You can go there in the Mac Heights and Kayan Tower. But the story behind all this is there has to be a sizable collaboration between all the parties involved. If one goes on tangent, then nothing will get sorted. There's another project here, again, within the financial districts of Dubai. We had adjacent property, and then the main structure was going ahead, main tower, and then the basements, and then this adjacent property could not obviously anchor through that. So we ended up putting some struts. So we excavated initially in this portion, open excavation, because there was sufficient space. And then we put in these struts against the main structure. And when you put in these sort of struts against the main structure, they transfer forces, right? All these struts, you are utilizing main structure to get the forces from the retention structure. So that means your main structure has to be designed to receive these sort of struts, whether it is with a spreader beam, whether it is direct punching shear, or you have to have some sort of a beam already designed into main structure and constructed here before you install the strut. So that's where, again, the structure engineering of the building has to interact with the geotechnical engineers and then the retention system contractors and engineers. So again, collaboration is absolutely critical in these sort of situations. Now there are a few challenges in both anchors and struts. Again, you can read through this, and probably it's all recorded, so you can see it on the recording. But critical aspect is struts are challenge for the construction of the main structures. They put in a lot of hindrances for smooth operations of machinery, equipment, labor, material at site. And the logistics also becomes challenge on installation of strut and removal of strut. Anchors on the other side gives you that freedom, but anchors have their own design life. Sometimes anchors have to be re-anchored if your excavation remains there for quite some time. Sometimes anchors have to be re-anchored if you have a flood condition, or you have some sort of soil loss of silt condition, and then your anchors become weak. So there's a bit of a challenge there on anchors. And then you can't do anchoring near the water bodies because you don't want to sort of create a easy path for water to gush through. So anchors have their own challenges. Similarly, struts have their challenges, and then depending on what suits for the construction activity, one has to check which option is better. Like whether it is diaphragm wall is better or secant wall is better. Exactly same thing. Whether anchored is better or designing cantilever is better. Sometimes you might not need all this, but you need a thick wall. Or use a strut could be an option. Now, some checklists from structure engineer's perspective when you are in this sort of deep basement construction activity. Now, what is I'm categorized that in various headings there, and it might be helpful for you to sort of you can add on points there, but I thought that these are some critical points. So design life is normally for our buildings are designed for 50 years, and sometimes buildings are designed for 100 years as well, because you have massive investment, thousands of crores of investment. So you're not going to demolish the buildings in 50 years time. So, but design codes they say that design life is 50, 60 years, depending on which code you use. But then if it is a temporary structure, then you don't have to worry about a lot of things. The shoring system itself, that if it is temporary in nature, and you are going to construct a permanent tension system, then you don't have to worry about the crack width, you don't have to worry about the grade of concrete. Okay, whatever is needed from the strength perspective, provide that much. You don't need triple bend concrete and GGBS and silica films added to that, or you don't need crack width calculation checks for shoring system, because shoring system is only for those 3 years or 4 years, and that's good enough for a normal concrete. But whereas if you are using shoring system as a permanent structure, like you're putting a diaphragm wall, or you put in a secant pile and want to construct a 200 millimeter thick RC wall in front of it, and then say that combined will act as your permanent retention system, then you have to be careful. Then all the shoring system that you are putting in has to have a defined crack width depending on the soil conditions and chemical and sulfate and chloride contents of soil. It also has to be designed for temporary condition with anchors or struts, and also has to be checked for permanent condition when it is resting on the each floor slab. So it will span between floor to floor. It may not carry the vertical load because you probably end up adding a vertical wall to take the vertical load, but sometimes even that is being considered as not required, the vertical wall. And what people generally tend to do is you put a diaphragm wall and then you connect your slabs directly to the diaphragm wall. But then challenges are getting the diaphragm wall in the panels in right alignment, and then getting the joints between the panels watertight. Is a challenge. It has been implemented I think it's been implemented in one of the projects in Doha. I don't remember using diaphragm walls as permanent structure in Dubai, but maybe some projects in India, they might have used it, but I don't have that information. So design life is one thing, that whether it is temporary or permanent. Then shoring type, depending on what you want in a permanent structure, what type of waterproofing, I think we discussed this, what type of waterproofing, whether you require, whether you have a bituminous system, or whether you have HDPE membrane, or whether you have a PVC membrane, or your vacuum system. So depending on that, whether that system requires a flat surface, or that system can accommodate the undulations of as is constructed shoring system. It has knock-on effect on the type of shoring. And if the quality of shoring is not good, as Mr. Vaishampayan said, that it might have to be chopped off. If you chop off, then you will end up having weak section in that area. Then, deciding when to chop off becomes a challenge, because you will have to construct up to a certain level so that the stress is relieved. Then you chop off that portion, then you construct the next portion. So it becomes more and more challenge in your constructing of the main building. Then comes surcharge. I think Mr. Vaishampayan has alluded to this. Actual load from the surrounding building. Sometimes we know what they are doing, where they are constructed. Sometimes we know they have a basement. Sometimes we don't. Sometimes you are not allowed to enter into that property, so you really don't know what's happening there. And then contractors themselves, they can put in a lot of surcharge surrounding your shoring system. They can stack up steel, they can stack up construction materials, they can have concrete pumps and concrete dumpers coming all the way to the edge of the shoring system. So based on the logistics of the contractor, based on the stacking area, based on the constraints, and making sure that the constraints are implemented on site, these surcharges can be defined. But normally you would end up designing for minimum at least 10 kPa, if not 20. But then there are projects where we have insisted on 20 kPa surcharge, because we knew that irrespective of what happens, contractor is going to, because the contractor doesn't have the space on other areas of the site, he is going to put in some sort of a stacking of material in that area. So irrespective of what happens, from logistic perspective, to allow that freedom to the contractor, we said, okay, let's design it for 20 kPa. Then comes the water. The shoring systems can be designed as a water retention system. Normally not required, but can be. If you are designing for that water retention system, then you have to consider that where is your dewatering well point? Are you lowering the dewatering behind the shoring system so that your water table is not significantly high? Then also you need to look at where are your dewatering well points inside the plot, and are they correlated so that they go out and at an appropriate location, and then discharge is connected to a main discharge point line. Then in a temporary condition, maybe shoring system may be designed for water, but in permanent condition, they will be taking only the earth load, and then your permanent retaining wall might take the water pressure. So you can split that, and then we have designed a couple of buildings that way. And then most critical, as I think Mr. Vaishampayan has also alluded to that, is toe level of retention system. that when you are dewatering inside the plot, what should not happen is water from outside gush underneath of the your shoring system and come up. Just because of the water pressure, it comes up on inside your plot. So you have to have enough embedment length into your shoring system. Could be any system. You have to have enough embedment length into the toe level has to be so deep that you are not siphoning that, or you're not creating that sort of a passage of water into the working space. Soil parameters, I think this is everybody knows this. Whether it is freestanding rock or what type of soil you have, K, K0, K0, K cannot at KP values, depending on, and again, this requires more of a geotechnical input. The structure engineer alone, you might know what is phi on a given type of soil, but when you have different layers of soil, it is best left with the geotechnical engineer to come up with, okay, this is the appropriate level of passive pressure, appropriate level active pressure, and then leave it to them to take a call that yes, this is the proper system in terms of soil retention. And then comes the concrete sections, and sometimes geotechnical engineers, some geotechnical engineer have capabilities of designing concrete sections, some don't. And then they generally carry out analysis and they give bending moments and shear forces, and then structural engineers has to put together the section parameters. Now, critical there is when you have diaphragm wall, rectangular sections, everybody knows that it's pretty simple. But when you have circular sections in bending and shear, then that becomes challenge. You don't have vertical load, not significant vertical load on this. So it's not going to act as a column, but it's going to act as some sort of a circular cross-section beam. So shear of that circular cross-section, you have to find out the appropriate method of analysis and design. Then you have to look at what sort of percentage of steel in those piles and whether it is making sense. Sometimes you might have 300 dia pile and you require massive reinforcement. It doesn't make sense because you will not be in a position to put concrete. So the diameter then becomes critical. The stiffness of that becomes critical. Then you have to have between structural engineer and geotechnical, there has to be a dialogue saying that yes, this works, this doesn't work. Likewise, size of cage and weight of cage. When you are constructing this, I think again, Supervision panel alluded to that during construction, cage might sink. You are holding the cage through a crane, it might sink when you are pouring the concrete. And the projections above that cage may not be sufficient to engage into the capping beam. So then you will have situations where either some of the bars are not engaged with capping beam, some of the bars are left without it, and the piles will just collapse. So that is another thing that structural engineers should be looking into, that what if the cage sinks? Do I have enough anchorage length into the capping beam? And then designing of the capping beam itself and designing of the weller beam. It could be steel, it could be concrete weller beam, and then the connections between the weller beam and the brackets. There could be welded connection, there could be bolted connections, and there could be anchor bolts. So all those design calculations, whoever does it, most likely it will be a structural engineer's job. Could be structural engineer working for geotechnical engineer or structural engineer working independently. But at the end of the day, it has to be checked so that there are no undue or untoward incidences at site. And depending on again whether it is permanent or temporary, you need to consider the crack rates and concrete mix and cover to the concrete. And then comes the anchors and struts. So anchors, somebody asked question about how you define the anchors. There are methods available to test anchors. Indian codes have them. I don't have, I'm not using Indian code for this, but there are 3 types of tests in BS 8081, which you can read through the BS available in Google. And then these anchors have to be designed. Then there has to be testing like piles. We carry out some preliminary test piles. Similarly, we have to do some proving tests for anchors so that we validate our design. And once the design is validated by proving test, then you can utilize that design for the following anchors. And then you carry out some sort of a acceptance test during the installation of the anchors. And then there are intervals, and then there are a number of tests that are required to be carried out in terms of percentage. Each code has its own limitations, so depending on which code you follow, carry out those tests at site. For struts, it is pretty straightforward. Sometimes the struts are proprietary design, but suppose they are not proprietary design, they are basically compression members, circular compression members with a freestanding length of whatever that length that you have. But challenge there is, you're designing the strut for horizontal, but then the self-weight of the strut act as a vertical load. So effectively, struts are subjected to, they're kind of an horizontal columns. So you have a bending moment into that, and you have an axial force into that. And the longer the length, the more is the bending moment, and the less is the capacity of the strut. So sometimes people do, depending on the what size are required, what size is available, you probably end up doing some sort of intermediate support, vertical supports to the struts, just to reduce the self-weight bending moment. And then once you have that sort of support, again, that has to be coordinated with its own foundation, the main structure's foundation, and location of that should not affect your columns, because eventually it will be a temperature, it will be removed, but during construction, it should not obstruct your construction of the main structure. So these vertical supports to the struts have to be correlated. And then load transfer, whether it is anchored or strutted, the anchor position with respect to the slab levels have to be predefined, so that you don't have a situation saying that, okay, I'm constructing a slab, but my anchor has to be distressed before that, so I have to design a cantilever retaining wall for some period, or I'm constructing a slab, but my anchor is exactly at the slab level. So how am I going to distress it? Or similarly, my strut is exactly at slab level, I cannot remove the strut. So again, this becomes more of a coordination thing, and structural engineer plays a vital role here in setting up the locations of anchors and locations of the struts, because that is a headache if you don't do it properly. And remember, when you're doing it, your main enabling works contractor may not be there at site. All his machinery would have already gone, and your main works contractor will have to take that responsibility. So when you are setting up the contracts between the enabling works and the main works, the handing over process between the two contractors, if it is single contract, and if it's a big contractor having subcontractor, it becomes much easy. But invariably that will be the case. So you will have two separate contractors, and when you are handing over the project, it has to be handed over in such a way that the main works contractor takes over and says that, yes, I agree to build in my the time and the cost based on these site conditions. And that's where it is, as a structural engineer, we have to be careful that where to put in these anchors, where to put in these struts, when to remove them, and if they remove it, then what will happen to the main structure, all those aspects. And that has to be discussed and thoroughly analyzed during the design of the shoring system itself. So when you remove the anchor and suddenly you have say 2 levels of anchor, and you construct it up to certain height, the main structure, and you remove one of the anchor, suddenly the 2 levels of anchor become 1 level of anchor, but you have a slab which is probably increasing the length of the between the first level and the second level of anchor. So that means the shoring system in that condition, construction phase condition, might be subjected to higher bending moment. And that's why it is critical that during the design itself, you design for installation and you design for removal. Both the cases have to be thought through, so that we don't have challenges at the last moment saying that, okay, now my shoring system is not good enough to remove my anchors, and I have to remove my anchors, otherwise I cannot pass my retaining wall. So it becomes a bit of there are solutions available, but then there are costly solutions. So it's better to be thoroughly thought through and then work towards that. And then I think capping beam we discussed. Mostly these beams, Weller beam are, they are spreaders. The anchors are holding the shoring system, and the load is applied on the shoring system. And then the anchors are at certain interval. They are not necessarily at every pile location. They might be, they may not be. So the Weller beams then act as a spreader beam. Similarly, the tie beam act as a tying beam together. And then suppose one pile is bit weak, other 2 piles are strong. then it kind of spans between that. So design of these beams, again, it is not necessarily a permanent structure, but it has to be properly and thoroughly checked and designed so that you don't end up into challenges during the main works construction. And then comes tolerances into the shoring system. 1 in 75 is reasonably accepted on verticality. Sometimes it goes to 1 in 100, and sometimes it's 1 in 300 also for some very tight spaces. But 1 in 75 to 1 in 50 is a reasonable acceptance tolerance. That is for verticality, and then for position, depending on how good the contractor is, but you still have to allow for position tolerance. And when I say position, it is at the location of the file where we are constructing it. So that is around 50 to 70,000 position tolerance is reasonably okay. And then deflection of these systems, short-term, long-term deflection, you need to include into your overall analysis, overall tolerances, because that's a gap you should allow for between the main structure and the shoring system. And you can backfill it by either concrete, beam concrete, you can do probably earth filling with a compaction, depending on what photocouping system you're going to use. So these are a bit of a tolerance. And then there are analysis tools. Structure engineers are normally not required to know this, but it's always good to know that how the design has happened, whether all the stages of the construction are considered in the analysis. There are Mr. Vashipan alluded to, there is Oasis, there is Fluxus, which is probably high end, then there is Reward, and then there are in-house spreadsheets from various geotechnical and structural consultants. This one here we used for anchor free tendon length calculation for a 6-way spin deep on the right here, on the 6-way spin deep construction. So analysis tools is, I wouldn't only bother about it, as long as it is properly thought through. It can be hand calculation also if it is not that complex, but it has to be thought through, saying that, okay, I'm going to construct this way, and I'm going to erect this way, and I'm going to de-strut or de-anchor this way. So all these aspects are, once they are thought through, then any tool is, it's good tool. And that kind of brings to end of my presentation.
Yeah, thank you, sir, for the very informative presentation. I'll request everybody to put their question in the question answers box. Meanwhile, I'll like to ask one slightly non-technical but related question. In India, as you must be aware, geotechnical engineers are not having any statutory responsibility as far as any enabling structures are concerned. What are the global practices in this? Since we have done various countries, what are the global practices related to statutory responsibilities as far as all these soil retaining structures are concerned?
So it is not explicitly stated even in Dubai that who is responsible on any statutory sort of document. But what it says is, normally the shoring systems are designed by the specialist contractors.
Contractors, correct.
Yes. And then the responsibility of construction, design, and erection, removal, all lies with those contractors. And if somebody is designing for them, whether say I'm a structural engineer and I'm designing the main bed, and under a separate contract, I'm also helping the contractor to design the shoring system, a structural design of the shoring system. Then under main contract, I may not be liable, but under that separate contract, which I've signed with the enabling contractor, I'm liable as a structural consultant. And
but
then
as a structural consultant only, no? But
yes. Now, sometimes they have in-house structure teams. Sometimes they have in-house only geotechnical team, and they reach out to structural consultants to provide design. And then sometimes there are completely independent structural consultant working for contractor and independent structure consultant working for the main works.
One more related question, Abhijit.
Yeah.
In your third or fourth slide, you had mentioned about authorities. So are there stringent rules regulation for submission of design to authorities?
Yes, absolutely. So when we design this sort of, I don't know which anyway, I'll probably. So when we design this, here it is, authority requirements. So there are two aspects. One is authority requirement in terms of placing of the shoring system, where that shoring system should be. Should it be directly on the plot line? Should it be away from the plot line, inside the plot line? Can it be slightly outside the plot line? And depending on which part of the city you are, there are rules would vary. In Dubai, it was around 600 millimeter outside the plot line was accepted in certain old Dubai areas, whereas in new Dubai area, especially in Burj Khalifa and the new north side of the north side of Dubai, was it not? Sorry, south side of Dubai, it is not allowed. So you have to put in inside plot because it's a brand new thing. So you are not allowed to go anything outside. That's one aspect. Second aspect, obviously, authority requirement is the level at which your permanent structure, permanent shoring system should stop. And when I say permanent, it's a concrete shoring system should stop because there are services running in the roads, and those services have to come inside your basements at certain level or certain location. So generally, they tend to push in around 2 meters is where your capping beam should be below your surrounding level, and you should put in an I-beam and slab panels above that, so that that particular soil is retained and those things can be removed later on. Your soil can your services come in. So that's from positioning perspective. Now from the design perspective, a proper calculation is expected from authority, has to be submitted and vetted by a peer reviewer. And when we say vetted by peer reviewer, it has to be vetted for all the potential conditions that shoring system is going to undergo during construction, during dismantling of the shoring, anchor, de-anchor, strut, de-strut, all those conditions. And during that submission, a structural consultant is supposed to write, and that's what the clarity of thought I was saying. The structural consultant should write a paragraph or two saying that how they envisage the construction to happen. So the design of the shoring system, whether it is independently done, and the consultant who's on the project appointed by the client, they work together and they say that, okay, this is what I'm going to do. This is how the construction will happen. These are my stages of construction, and a shoring and de-shoring and strutting and de-strutting has to be designed to that. And then all that package has to be vetted by a peer reviewer and then submitted to authority. So that's the process followed.
Yeah, that's a good.
So they are depending on peer reviewer, or they do have their own staff? Dubai municipality.
Dubai municipality has their own staff. They, what happens there is then the designer and the peer reviewer has to go together, and then they have to present it together to Dubai municipality, and then they have their own engineers, and then these engineers, depending on the complexity of the project, they vary. There are grading in those engineers. So most of the time, all my projects were like there were two senior engineers sitting there, one asking questions, other one just observing what I'm saying and then questioning me back on what I said. It kind of becomes a bit whammy, but it was interesting discussions. So we had to have in-house discussions before we go to municipality, saying that peer reviewer, structure designer, geotechnical consultant, okay, these are the potential challenges. This is what may happen. These are the questions that Dubai municipal engineer will ask. This is how we have to answer. So there's kind of a dress rehearsal. And then you go there, you go prepared, and then obviously, despite all this, there are challenges, there are failures. As I said, that failure happened on Infinity Tower. It was, you can see on YouTube also, it is there. And then, the problem is, it's not the technical people who will cause an issue. It is the non-technical people who will cause bigger issue. Suddenly people will take photos, and suddenly social media, Instagram, WhatsApp, everywhere, Dubai failure. And then suddenly you are like, what is Dubai doing? And people are already, some people might be already frustrated because of this. They will, write, pages and pages about it. So it is, once the failure happens, very difficult to control.
Thank you, Abhijit.
Yeah, thank you, sir. There are not many questions here. only one question is there. Have we ever come across the soil retention system which, after serving for excavation activity for basements, can be used as part of main structures?
Yes, we are designing
Yes,
that way
yeah,
on
yeah.
one of the projects. Yes, it is possible. But then it has to be designed as a permanent structure. You don't want to corrode that structure. I hope it was useful. I mean, there's no question that means people are not interested.
No, no, it's not. It's like that. It is the information is at very different level, so it's very difficult to what you can ask any
Could be.
technical question in that. Actually, that may be the question. That's that, but it was very
Could
well
be.
good, and there's something which we don't come across in practice in India. Thank you,
Yeah,
sir.
I mean,
Yeah, yeah.
thank
One
there's
second.
lot of
Yeah, yeah.
yeah. Please carry on.
No. I thought one question is there, but there is only a comment. Very informative. Yeah, that's all.
So look, Indian construction activity. I think we have to do a lot of catching up.
Yeah.
I've seen a lot of sites. Even I'm my third year in India now, and then the first 2 years have gone into pandemic anyway. But visiting all the sites and going through how the things have been built, I think there's a lot of learning and unlearning.
Yeah. More of unlearning.
People are saying that this is how we have been doing for the last 20 years. Yeah, but that's not correct. That's how people. It's not that everything is bad, but there are better ways of doing it, and I think we should embrace those better ways.
Yes, that's right.
Okay, so thank you very much for giving me an opportunity.
Yeah.
Thank you.
We have, please. Right. I think I'll request Mr. Jayan Kulkarni to give a vote of thanks to conclude.
So first of all, I will thank both the speakers. Excellent presentation by Vaishnapan, step by step. All the things are explained like a textbook, and it can be used as a reference lecture. And maybe we can have supplementary lecture to whatever he has said or what is he has not said. We can supplement it by that. Abhijit Kulkarni gave a different perspective, is what is happening all over the world, not exactly all over the world, at least in Gulf countries, and different kind of experiences, what we normally don't get here. I had quite a few of my friends working in Dubai as from contractor, as consultant, and I had been hearing from them about a very stringent requirement of the municipality and very good engineering teams with the municipality. Some of the glimpses we could see on other side, what consultants have to face, and I like the idea of having an in-house debate or presentation or test trial before going to municipality. It shows how meticulously things are checked. And with that, there are not many senior persons present in audience, in the sense present online. I thank all of them. I thank all the participants, which also include students at many places. Before we end, I must say that what services we as Epicons offer. We are in structural design, proof checking of tall building, structural audit, assessment of humidity, concrete quality monitoring services, project management consultancy, architecture and detail engineering, and of course, training through EFC. Let us wait for our next announcement of webinar 136. Please give your suggestion for the topic which you desire. With this, I declare that today's webinar is over. Conference is over. Thank you.
Thank you. Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Yeah.
Thank you.